Greetings, Dr. Daniel. My name is Quentin, and I'm the group leader of Group 8. The title of our project is Molecular Weight Analysis Calculator. Our group comprises of me, myself, Quentin, Sherlyn Cheong, Ado Ng Yi Tian, Li Wenjin, Lee Xiang Jin, Kang Jun Yi, Muhammad Amir, Noor Raihan, and Muhammad Amin. Next, I will let my group mate to discuss about the problem statement of this project.
Hi everyone! Have you ever spent hours calculating the weight of a molecule in chemistry class only to second guess your answer? Figuring out how much of each element makes up a molecule weight can be a real pain, especially with those complex ones with lots of different atoms. That's why we built this awesome software application. We use Visual Basic 6.0 because it's easy to use and lets us create a user-friendly interface. This means anyone with basic computer skills can pick up and use it. No more tedious calculation or worrying about mistakes. This software does all the work for you, giving you the exact answer you need in seconds. It's a lifesaver for students, educators, researchers, and anyone who works with chemistry.
Molecular weight is essential in various branches of science and engineering, such as chemistry, biology, biochemistry, pharmacology, and material science. Each play a critical role in calculating how molecules interact during chemical reaction, predicting reaction yields, and ensuring accurate stoichiometry calculation. In analytical chemistry, molecular weight is instrumental in determining molecular concentration, preparing solution with precise proportion, and quantifying substance in complex mixture. Moreover, molecular weight significantly influences the physical and chemical properties of substances, such as boiling point, melting point, diffusion rate, osmotic pressure, and reactivity. In biology and pharmacology, knowing the molecular weight is biomolecules like proteins, DNA, and drugs help researchers understand their structure function relationship and design efficient drugs delivery system. Molecular weight.
The primary objective of the molecular weight analysis calculator is to provide a precise, efficient, and user-friendly tool for determining the molecular weights of chemical compounds. Our tool aims to simplify calculation by automating the process of the molecular weight determination and eliminating the need for manual calculation, which can lead to human errors. This can lead to a boost in productivity as it saves time for students and professionals as it provides them a quick access to information. For example, atomic masses and the percentage of a specific element in a chemical compound. Thus, the molecular weight analysis calculator aims to bridge the gap between theoretical knowledge and practical application so that the users are able to perform molecular analysis with ease. The
Hi, I'm Ada and I'll be proceeding to the graphical user interface. So for this part, we have three forms. So the first form is the homepage form. This form consists of two command buttons and also one label box. So the label box is the welcome word, and then the first command button is the molecular weight calculator, and then the second one will be the percentage mass of atoms in compound button. And we also include a background image using the image box function. Alright, proceed to the second form, which is the molecular weight calculator. So this form actually has more things. The first one is the text box. So we have text box right beside the molecular formula and also molecular weight for the user to input their data. And then we have a combo box for the user to select a compound, and then a history section by using the list box function, and also three command buttons, which is calculate, clear, and back.
Good afternoon, Dr. Daniel. My name is Li Wenjin from Polymer Engineering course. Now I'll be explaining about the interface of our second part, so about the percentage mass of atoms in the compound. So this interface consists of several controls like text box, list box, and command buttons. For the clear, calculate, and back buttons, we are using command buttons to do it. So for the text box enables the users to enter their molecular formula and get the result. For the result, we are using a list box to display our result. So there are several results like percentage mass, number of atoms, and mass of each element. So we also have a history box, also using a list box to display the previous result, previous percentage mass of the molecular formula entered.
Alright, I will continue with the demonstration of our system. So we will press the first command button, which is the molecular weight calculator. And then you can input your molecular formula in the text box with the correct format, which is uppercase. And then you can press calculate to calculate the molecular weight, and then it will appear at the text box and also in the history box. Next, you can press the drop down button to choose the desired compound. So if I choose water, then you press calculate, then it will show its molecular weight and also in the history box. This compound is the common compound in daily life. And then if you press clear, it will clear the text box and then back to the home page. Next is the percentage mass of atoms in the compound. Same thing, you can just input the molecular formula and then press calculate. It will show you the mass percent, like carbon has how many percent in this compound. And then next is the number of atoms, like carbon has 2 atoms. And then mass of elements in the compound. So like carbon has 24 gram, like that. And then all this information will show in the history box also. Then you press clear, it will clear the molecular formula text box and then input the new formula, then you can get the new information. And then all this information will be in the history box. Yes. And then next, after this, you can press back and then it will back to the home page again.
Good morning, Dr. Daniel. I'm Charlene Chong Sushen. I'm currently going to explain about the homepage. So our homepage has actually 2 buttons. One is the MWC click, another one is the PCTM click. So for the first section, which is the MWC click, so when it's clicked and then the form for MWC will open and current form, which is the homepage, will close. And then after that is for the PCTM click. So basically it's the same. When the PCTM button is clicked, the form for PCTM will open and then the current form will also hide. And next is the third section, which is the form load. So when the home page load, it will adjust the display order of its control so that the label 1 will be visible on top and image 2 will be behind. Good morning. So I'll continue by briefly explaining form 1. So starting with option explicit dim atomic weights and collection. So basically this part is to ensure all variables are declared before using and then can help to catch errors and improve code readability. And the collection part is that this code actually declares a collection name atomic weights to store atomic weights of elements. Following next, starting from the private sub CMB formulas click is basically for the CMB formulas click button. So when the drop down of CMB formulas is clicked, it will be copied into the TXT formula input box. And starting from the private sub form load, basically this section will run when the form is loaded and performs following tasks. So for the set atomic weights equals to collection, so basically this is when a collection is created to store the atomic weights elements, the code will give entries for common elements given. For example, the element symbol is H and the key and its atomic weight is 1.008 as the value. Same goes to the rest of the elements. So
This calculate molecular weight function computes molecular weight from a chemical formula, handling brackets and multipliers. It uses a loop process each character. When it encounters an open parenthesis, it pushes the current weight to a stack and resets molecular weight for inner calculations. On the closing parenthesis, it calculates a multiplier from digits following the bracket, defaulting to 1 if none exists. It then multiplies the inner weight by the multiplier and adds it to the previous weight from the stack. This method accurately processes nested formulas like H2O2 NaCl using the stack to track weights and ensure precision. It's a clean approach to parsing and calculations in Visual Basic. This section of calculate molecular weight identifies elements and their atom counts from the formula. The code starts by extracting the element, ensuring the first letter is uppercase and appending a lowercase second letter if valid. It then reads digits following the element to determine the atom count, defaulting to 1 if none are found. Next, it uses the atomic weights lookup to find the atomic weight. If the element is recognized, it adds the weighted contribution to molecular weight. If the element is unknown, it shows an error message and exits the function. This logic ensures accurate parsing and error handling for chemical formulas, making the function robust and user-friendly.
Hi, I'm Ng Yi Tian, so I'm gonna continue from here. So when you press the calculate button, the program first retrieves the formula you type into the input box. It checks if the input is blank or still have the placeholder text. If so, it stops and prompts you to enter a valid formula. If the input is valid, it calls the calculate molecular weight function. So this function will break down the formula into its element and calculate the total molecular weight. So if it can't understand the formula, it will return to a zero and an error message will be shown. If the formula is correct, so the molecular weight is displayed in gram per mole and saved to a history list for future reference. The input box is smart too, so by clicking inside it, it clears the placeholder text. So if you leave it empty, and the placeholder text will return automatically. So the clear button also reset the input and result, while the back button will just navigate you back to the home screen. So it's make the program user friendly and easy to navigate. Okay, that's all.
Good morning, Dr. Daniel. I'm Li Xiangjun from Polymer Engineering. Today, I'm going to explain the code for the second form. So start from the option explicit, which ensure all the variables are declared before using. Then it will declare three variables, which is atomic weights, molar mass, and calculation successful. Then when the back button is clicked, the current form will be hidden and the home form will be displayed. Then it will hold the chemical formula input by the user, clear all the items from the list box, one control, and sets the calculation successful variable to false. If the formula is empty, the program will display a warning message, please enter the formula. If the formula is invalid, the program will display a warning message, please enter the formula correctly. Then it will initialize elements to hold the part structure of the formula and then break down the input formula into its components. For this script for codes, if the parsing fails, the program will safely exit the subroutine. Then it will compute the molar mass by summing all the contribution of the elements and calculate the mass of the elements. It will determine the relative contribution of the current element to the compound overall mass and ensures that the mass current is shown with exactly 3 decimal places and the percentage is with 2 decimal places. Then it will process all elements in the chemical formula, calculates their percent composition, mass, and atom count, then formats them. For this script of code, it will add the formula and calculator result into the second list box when the calculation is completed successfully. It will also allow the user to clear the input field and reset the list of results for new calculations. Then it will create and populates the atomic weights dictionary with the atomic weights of various elements in the periodic table. For this batch of code, it will add.
Hi, my name is Tuni. So today I would like to introduce about the pass formula function and the isValid formula function. The pass formula function is process a chemical formula string and convert it into a structured dictionary of elements and their counts. It looks through the formula character by character, identifying elements by their symbol, which may include one or two letters. If the symbol is followed by the number, it extracts the number to determine the count of atoms. If no number is present, the count defaults to 1. The function checks the identified element against the predefined atomic weight list to ensure it's valid. If the element exists, it adds the element and its count to the dictionary, combining counts for duplicate element. If the element isn't recognized, it shows an error message and exits. Once complete, the function returns the dictionary containing all elements and their counts, making it a critical step in passing and validating the chemical formula. The isValid formula function checks if a given formula is syntactically and chemically valid. It starts by assuming the formula is valid and iterates through the string character by character. It first ensures that each element begins with an uppercase letter. If a lowercase letter follows, it combines them to form a valid two-letter element symbol. Next, the function verifies if the symbol exists in atomic weight dictionary. If the symbol is found, it marks the formula as invalid and exists. It also skips over numeric values that represent atom counts to continue passing the rest of the formula. By combining the symbol validation, dictionary check, and number handling, this function ensures the formula conforms to chemical notation rules. If any issue is detected, it stops and returns false. Otherwise, it returns true, confirming the formula validity.
That's all for our presentation. Thank you for watching.